graph the region defined by x is greater than or equal to 0, y is greater than or equal to 0, and 2x plus y is less than 6. So whenever you get something like that, we're going to need to draw the lines of not the equals bit, but the equals bit. So we need to draw 3 lines. We need to draw x equals 0. We need to draw y equals 0. And we need to draw 2x plus y equals 6. So the last one will certainly be the hardest, but it won't be too bad. We also need to know whether we need to draw them with a solid line or with a dashed line. So the rules for regions, if the line is included in the region, then that's a solid line. So the first one, it was x is greater than or equal to 0. So the actual line is included, so that can be a solid line. The second one is also y is greater than or equal to 0. That can be a solid line. The third one, it was 2x plus y is less than 6. So the line is not included. So that will be a dashed line. So once we've drawn these things, then we'll think about turning them into inequalities by shading the unwanted area, and then we'll be left with the region once we're finished. So the line x equals 0 is just the y-axis, just all the way along it. The x coordinates are 0. So if we just go straight for the line, hopefully you know what that one looks like. It needs to be a nice solid line, and it needs to be going through here. So x equals 0 is that line there, and then we'll just label that x equals 0. Right, then we need to think about shading. So we are interested in x being greater than or equal to 0. That's the bit we want. So that would be the right hand side. So here, all the way along this line, x is 0. So the wanted region is the other side. So what we do instead, and this is kind of specific to the exam board, they actually will sometimes tell you shade unwanted regions. But when you've got 3 lines, it's more efficient anyway to shade out the unwanted region each time, and when you're finished you're left with the wanted region. So we're going to shade the opposite of x is greater than or equal to 0. We're going to shade when x is less than 0, which is the other side. We're just going to do it in this sort of style. What you don't want is a really big block of actual heavy shading in. Just a little bit of hatching will be absolutely fine. Something like that, and just make sure we know that this region is not something that we want. Okay, I think that'll probably do. So the next line, y is greater than or equal to 0. This one again, as we've said, it's a solid line because the line is included in the region. Y is equals 0 is the x-axis, which looks like that. So we just draw this here, and the bit that we want is when y is greater than 0, which would be y values above the line, y equals 0. So we're going to shade the unwanted area which is below the line. So we are going to do this nice hatching again up to the line. We're shading out the bit we don't want, the unwanted region. Try not to go over too many numbers. Okay, right, so the third line, this is going to be a bit more complicated. 2x plus y equals 6. Now you could, for something like this, you could say, well, y equals minus 2x plus 6, which would mean that it goes through at 6 and it has a gradient of minus 2, so it goes along 1 and down 2. In fact, it probably would be easier. Your other option would be to think, well, if x was 0, what would y be? If y was 0, what would x be? Which you could do. You could say, well, look, if x was 0, then 2 times 0 plus y equals 6. So that would be 0 plus y equals 6, so y equals 6, which means that when x is 0, y is 6. That is a point on the line. And then you could do something very, very similar for y being 0. So then that would mean that 2x plus 0 equals 6. So that would mean 2x equals 6, which would mean x equals 3 would make that true. So when x is 3, y is 0. So you've got 2 points on the line. Either way, we're going to have the same line here. Okay, so if we plot a point at 0, 6, so none along, 6 up, just here, and we do the same thing at 3, 0, which is just there, and then if we join the line through there, it should be the right line. But let's just have a think about this gradient approach as well. So it would start at 6, so we already have 0, 6, the y-intercept, and then from there it goes 1 along and 2 down, so it has a gradient of -2, so 1 along, 2 down, so that would be a point as well. 1 along and 2 down, and so on. You can see it's exactly the same line. Okay, now this line, remember, needs to be a dashed line because the line is not included. So if we kind of draw it like that, I'm going to have to make sure I cover that whole thing. Obviously, with drawing it with a ruler, you wouldn't have to mess about like this. But my line is going to do something like that. Okay, and that is the line 2x plus y equals 6. So just make sure everything's labelled nicely. Then I need to shade out the unwanted region for this, which would leave me with a wanted region. So what we want is when 2x plus y is less than 6. So less than means sort of to the left or underneath the line. So this is the bit we want. So the bit we don't want is when it's the other side, when it's greater than, when it's above, or so when it's above or to the right. Okay, so we're going to start shading out some unwanted regions. Just like that. And there, so we've shaded out everything we don't want. So what we are left with is this region R in here, and that's the area that we do want. So now we label the region clearly with an R, and that is the region. Now don't forget these lines, this line along here is part, so you're in the region if you're along this line, that x equals 0, and you're in the region if you're along y equals 0. But if you're along the line 2x plus y equals 6, that does not count as part of the region. So that's, right now we've just been asked to graph it, and that's what we've done. But just be aware, there could be follow-up questions in an exam situation.